Hi sir. Firstly, I want to introduce myself. My name is Mustafa Özenç. I'm studying mechanical engineering. We are doing this project with Ismail Furkan Sarwan. In this presentation, I am going to explain what is the neural network, what is the artificial intelligence, and what we did in this project. What is the artificial intelligence? In the simplest term, artificial intelligence refers to system or machine that mimic human intelligence to perform tasks and that can recursively improve themselves based on the information they gather. Artificial intelligence manifests itself in many ways. For example, intelligent assistants use artificial intelligence to pull critical information from large user-defined datasets to improve timing. Suggestion engine can automatically offer suggestions for TV programs based on users' viewing habits. Competing at the highest level in strategic game systems, such as chess and Go. As you know, the artificial intelligence are using on automobiles, autonomously operating cars. All these examples are currently used. As you can see, there's a simulation here, and the vehicle you see on the screen tries to reach the finish line. However, the important thing here is that the vehicle does all of this without needing a human ability. The vehicle tries to find its own rotation by a means of an algorithm designed before, so it uses artificial intelligence. However, in order to do all this, a number of equipment is needed that artificial intelligence needs. One of the basic equipment is sensor. As you can see in the video, sensors are used to detect the walls. According to feedback received from the sensors, new methods are constantly being tried to the neural networks you see in the screen upper right corner. And finally, the vehicle reaches its goal by finding the correct rotation after hundreds of attempts. It must be somewhere in here. It reached the goal. This small two-dimensional simulation in which car learned to maneuver toward a cause by themselves using a neural networks and evolutionary algorithms. What is the artificial neural networks? Artificial neural networks parallel and distribute information progress structure inspired by human brain consisting of process elements, one of which has its own memory. Other applications are computer programs that mimic biological neural networks. The basic elements of biological neural networks are biologic nerve cells. The number of nerve cells in the cortex, part of the human brain, is approximately 1011, and each cell number in mutual relationship with other cells ranging from 1000 to 10,000. As you can see in the picture, the basic element of the nerve cells are the nerve cell body, dendrite and axon. Simulation from the nerve cell from other nerve cells are carried to the cell body through dendrite and transmitted to other cells by axon in chemical progress caused by disruption of intraocular activation. Synaptic space between axon and dendrites play a role in the transfer of stimuli to other nerve cells. The synaptic wiggles within the synaptic space are elements that condition the incoming stimuli to pass to other cells through dendrites. The filling of the neuroconductive material provided by the synaptic wiggles into the synaptic cavity condition the passage of impulse to other cells, changing existing synaptic relationship between cells or establishing new synaptic relationship between cells corresponding to the learning process in accordance with the stimuli coming into the cells. A neural network is a network of circuits or neurons, or in a modern sense, an artificial neural network composed of artificial neurons or nodes Thus, a neural network is either a biological neural network made up of real biological neurons, or an artificial neural network for solving artificial intelligence problems. The connection of the biological neurons are modeled as weight. A positive weight reflects an excitatory connection, while negative value mean inhibitory connection. All inputs are modified by a weight and summed. This activity is referred to as a linear combination. Finally, an activation function controls the amplitude of the output. For example, an acceptable range of output is usually between 0 and 1, or it could be -1 and 1. A Stirling engine is a heat engine that is operating by a cycles corresponding and expansion of air or other gas at different temperatures, such that there is a net conversion of heat energy to mechanical work. More specifically, the Stirling engine is a closed-cycle regenerative heat engine with a permanently gaseous working fluid. Closed cycle in the context means a thermodynamic system in which the working fluid is permanently contained with the system, and regenerative describes the use of a specific type of internal heat exchanger and thermal store, known as the regenerator. Strictly speaking, the inclusion of the regenerator is what differentiates a Stirling engine from other closed cycles hot air engines. This is the Stirling engine system model, and this is our Adams design of the mechanism. As you can see here, there's a database. We researched for 1 million trails for each of the 6 algorithms in the QuickNet program. Throughput for online backprop. This is the first one is the error and training time chart. The second one is the output target pattern for node chart. Throughput for online backprop round. Throughput for batch backprop. Throughput for delta bar delta. Throughput for RPROP. Throughput for quick probe. And this is our three-dimensional model from the neural networks QuickNet program, from the QuickNet program. And this is our system. Thank you for listening to me. I wish you healthy days. Thank you.